Got it. I'm going to be doing this one for my third day review tomorrow. I feel pretty confident. I got a couple days underneath it. There shouldn't be any extremely wild curveballs. Like a first day, you don't even know people's names, getting stuff coming at you. That's going to be a little bit of this early phase. Like at Paul Dirac, very good. We're going to check him out later. If I wanted to really do it, I would use Richard. I don't remember his name, but he talks about specifically Paul Dirac's equation about on the far end where the electron model was wrong. So when you apply it inside of this point of view, which is I photon times the derivative of a wave function equals an m for my. This is basically I photon derivative of wave function equals my. And this is something you should be really familiar with computer engineering nowadays. That's this time period of numbers when you started that. They're kind of subjective to years round the ball since 2,000 years ago, or well, for them, 19.84 years as far as a cornerstone or a way to describe said wave function. So again, for my work tomorrow, along with many other things we'll be doing. Got to get past this first part. Again, a couple days. There's the first two for sure. Kind of sorted out. Liked them on that. Compare other arrays for things when you're going through it. And still feeling out the irrational photon. This derivative in a wave function where it be loading, working with the forklift. So you'll hear a video like this tomorrow at, the 15-minute or 10-minute or 30-minute break, probably 30, just to make sure you get it in there half day, and that way for sure you got that monster by yes, all those things. But when you're doing this, how do you specifically open that Master Mason video and describe a specific one of them, and then turn right around, because you got to do those two in the same system. One be irrational, h bar, Planck's constant, the smallest number or the coldest temperature. And that's to say that's what that is. If it was a temperature, and that's the gauge we're using to measure, working back this way, well then this high-low, right, charge is high-low. You got this high point here, which is anytime that pinged twice, gold, silver, you'd hit a stoichiometric ratio where it balances out on some kind of curve, where any two derivatives are going to be like the lower end Fourier of it. So if we're doing blade rotations and blade changes on a maintenance, it wouldn't be a direct time, but that time would come off very specifically. Not necessarily the curve on the blade, because there's no measurement that's perfect. Are you with the line, without the line? The saw is going to do what the saw is going to do when you put X, Y, Z together. It'd be X, Y, Z, or you could go X, Y, Z. It does them both. This will happen. The end result's already baked in from the first few movements. Started the day, had a nice clean set, because ours start from the day before. It was my first day and second day. Between here and here, we're going to say that there was a derivative of a wave function, while thermaling and catching would be the example. Now this could be a little bit more specific, because it could be either of those things in any given specifics, just fx or ax, or a derivative of x, when you need those two other points to say that's the new temperature, that's the new measuring. It describes what 0 or 1 would be. In this case, processing through, yes, anybody in any range of the extreme. A 2-year-old baby, an 18-year-old kid, right? There's quite a bit of subjective difference inside of what that is in any units or places where they could come through. So when you're looking at something like dimensional stone and you're looking at yard configurations, this is another thing that goes into it, because those saws will need to be maintained, and while they're being maintained, you're probably going to be ahead of the game, because it's a technical down on some side of the situation. This gradient that says, well, when it does this flow of energy comes up here on what would be subjectively the high line. So again, it's a rational number, which is the square root of -1. Where's your fail points? This is the low end, this is the high end, and you can kind of tell by the geometry of faith here. The derivative of a wave function is any point that's a temperature, a height. There's one point on a line, it's time, which is again more numbers, so you gotta get used to that. Like time, that's gonna be minus this original system. Why is it minus? Because we didn't know at this point in time. Now we know something at this point in time. We're subtracting the electromagnetic storm off of the star. This, in early mechanics, that's got to be Big Bang, and that's generally why you have a problem with homogenizing protons and neutrons from this early universe, right? That runs the line to the first day, first week, first month, first year. Because sunshine does that in such a way at the limit of gravity. Hydrogen on planet Earth, hydrogen. Plasmic hot, they range from that. They definitely do that on wave functions. It's not negotiable. I hate to be that way. So again, first order would be first days, first weeks, first months, first 5 years, first 30 years. Would be a difference of those second order derivatives and space derivatives, because that gives me real XYZs. Anybody else could recreate. Anybody stand in a field and track the sunshine, summer to winter, right? More sunlight, subjectively, dusk till dawn. But against that, this solar powered system kicks on, right? Well, that's just write down the time on when it turns on and when it turns off, and that's the distance. As long as over the course of the year, you'll see that shrink and raise accordingly, given on what your perspective is on the ball, because, 23-degree tilt is going to have that index plus the top of the ball, the bottom of the ball, right on the equator. So we have to homogenize that. Kind of in phase space about being an x of the derivative. Now that we have those forces, you're going to create things that you wouldn't see normally without the maintenance log, or predictability by choosing to go through those data tables, where we, just subjectively dusting it off, running the gambit or the system. Let me just open the Codex Astartes, roll against Tyrants. Whatever that is whatever it is. What gets me going on that would give me a specific type of variable. It seems like that's going to be the negative, and inside of there, because that adds to the entire equation when you subtract that from what the biggest issue is. There's sunshine. How much hydrogen? Nobody's really sure. Can't be too precise there, even though it's not the Milky Way's distance away. We have temperature issues that wouldn't be so perfectly finite that you could be able to say Betelgeuse or our sunshine is specifically going to be eating us with the spin on things to be able to handle that. So you don't want to. You want to be able to bust that down. It's a big old stone mill, right? And for our most part, I'm in the second order of the derivative. I don't do the quarrying right now. I'm not anywhere near the big 11s, 5s, 7 or 7s, 5s, or even a bridge saw that could put a 12-inch cake under it. So that means I have to reflect what the irrational numbers are inside of there, the square root of -1, based on not just failure, but super failure. Kind of Murphy's Law. You should be able to predictability all that's -1. So while going through the derivatives of the event through what I expect my timeline having to be, I'll get halved. But more to do it while you got the saws going on and, trucks going by,